In this problem, we're going to use Thevenin's theorem to find the power supplied by the 12-volt source. Again, we're going to use our problem-solving strategy entitled Applying Thevenin's theorem. In our previous problems, the load's always been a resistance. This time, our load is going to be, we can think of it as this 12-volt source. So we're going to remove the load and calculate the Thevenin equivalent for the remainder of the circuit. And once we calculate the Thevenin equivalent, we're going to hook the 12-volt source up to it and calculate the power supplied. So that's our strategy. Once we have this, we'll calculate the current I1, and that current will allow us then to calculate the power supplied. And if we look at our problem-solving strategy, the first step says remove the load, which is our source, and calculate the open circuit voltage. So here is the circuit. To do that, we remove the 12-volt source, and now we're ready to do calculations. In this problem, let's use mesh analysis, and I'm going to define mesh currents I1, I2. Now I'm going to define, since this is an open here, I'm going to define this as one mesh and have it be I3. Okay. So if we look, we have three mesh currents, I1, I2, and I3. We're going to need three equations. It turns out we're going to have a couple of constraint equations because we have current sources. Anytime we have current sources in mesh analysis, we have constraint equations. They're very easy. For instance, we'll have I1 equal to 8 milliamps, I2 equal to 2 milliamps, and then we'll apply KVL around this loop to find our third equation. So if we start here, these two resistors will have 8K times I3 minus I2 plus 1K times I3 plus 3K times I3 minus I1 equal to 0. And we'll have then minus 3K I1 minus 8K I2 plus 12K I3 equal to 0. And if we substitute our constraint equations in here, we'll get I3 equal to 10/3 of a milliamp. Now to calculate V open circuit, let's apply KVL around this loop. Now the voltage across this resistor is going to be 0 because there's no current flowing through it. So V open circuit is going to be 2K times I3 minus I2 plus 1K times I3. So we have minus 2K I2 plus 3K I3. So then the open circuit is minus 2K times 2 milli plus 3K times 10/3 of a milliamp. And that turns out to be 6 volts. Okay, so that gives us our value of the open circuit. Now if we take this circuit now and set the sources to 0 to find our Thevenin, so take this same circuit, turn this to 0, we'll be replacing it by an open, turn this to 0, replace it by an open. The corresponding circuit for calculating R Thevenin is shown here. And so now we just need to go through and do resistance combinations. For instance, we can combine these in series, and we can combine these in series. And these two are in parallel. Okay. So those they're in parallel. And if we calculate their parallel combination and add that to the 6K, we get the Thevenin resistance. So 9K and the 3K are in parallel. That tells us R Thevenin is 8.25 kiloohms. So now we've calculated the open circuit voltage and the Thevenin resistance. Our terminals A and B. Now we're going to hook up the 12-volt source. And now we can calculate the current I1. So I1 is 12 minus 6 over 8.25 kiloohms, 0.7273 milliamps. So then the power supplied by that 12-volt source is 8.73 milliwatts.